Welcome to Algebra 2B. We're working on the expanded review for Chapter 7. Now this video is just going to cover problems 1 through 12, which is all the equations in 7.6. So if we're starting with number 1, we have log of 5x minus 4 equals 3. And remember that if there is no base given, this is a common logarithm. So what we're going to do to solve this is we need to switch to exponential form. So I'm going to put my base, and we're solving for the exponent, so I'm going to have 3 as the exponent, and set it equal to 5x minus 4. 10 to the third gives me 1,000. And now I'm just solving a simple equation. Add 4 gives me 1,004 equals 5x divided by 5. And remember, our goal is to round to the nearest hundredth. So x equals 200.80. Okay, number 2. This one is given a base. We have base 7. So I'm going to do the same thing. Rewrite in exponential form. So I have 7 to the third power equals 3x. And now I just solve. 7 to the third is 343 equals 3x. 343 divided by 3. X equals 114.33. Number 3, we have log base 8 of 2x minus 1 equals 1/3. So I'm going to do 8 to the 1/3 equals 2x minus 1, rewriting in exponential form. 8 to the 1/3, and that's the cube root of 8, so we get 2 equals 2x minus 1. Add 1, 3 equals 2x, x equals 3 halves, or 1.50. Moving down to number 4. Now we're given an exponential form. What I'm going to do is I'm going to rewrite in logarithmic form to show you how to solve this. Okay, remember that this is our base right here. So that's going to be log base 7. And remember, we're solving for the exponent, so that's going to be on the other side of the equal sign. So it's log base 7 of 20 equals 3x. And now this is not a common logarithm, so we have to use change of base. So I'm going to do log of 20 over log of 7 equals 3x. That gives me a decimal, and I'm going to divide both sides by 3, so my final answer comes out to be 0.51. Number 5 is the same idea. Rewrite in logarithmic form. I have a log base 2. We're solving for the exponent, so x plus 3 of 512. Okay, it is not a common logarithm, so I need to write change of base. And now I'm going to get a decimal for common logarithm of 512 over log of 2. And I'm going to subtract 3 from there, and you should get x equals 6. Okay, number 6. Same idea, but before we do that, we need to isolate what the exponent's being raised to. So I got to subtract 8 first. So I have 10 to the 2x minus 7 equals 1,000. And now it's in exponential form. So I can rewrite it as log base 10 equals the exponent, 2x minus 7. So it's log base 10 of 1,000 equals 2x minus 7. And this is a common logarithm, so you can just do this on your calculator. Comes out to 3 because 10 to the third equals 1,000 equals 2x minus 7. Add 7, divide by 2, x equals 5. Okay, now we're moving down to problem 7. Natural log of 4x minus 1 equals 36. Now remember that a natural log is a logarithm with base e. Okay, so there is a base here, and I'll write it for this one. I will not write it for the rest of them. Okay, it's log base e. So now I can rewrite in exponential form. E to the 36th equals 4x minus 1. That's going to come out to be a big number. Okay, but remember it says round to the nearest hundredth. And when you put this on your calculator, you should get something that says 1.077807 e to the 15th. That's just like scientific notation. It says times 10 to the 15th, so the decimal place should be moved over 10. So if we're approximating, you should get 1.08, because we're doing it to the 100th, times 10 to the 15th. Or on your calculator, it will say E15. Okay, number 8, same idea. It's log base e, so I have e to the 6th equals 3x. If you do e to the 6th and divide by 3, you should get 134.48. 9, log base e again. So you'll have e to the 4th equals x minus 1 over 2. Take e to the 4th, you get 109.20 equals x minus 1. Add 1, you get 110.20 equals x. Okay, we're working on the last 3 problems here on the bottom of the page, numbers 10 through 12. It's given in exponential form, so let's rewrite it in logarithmic form. We have our base is e, we're solving for the exponent, and the last number fits that hole. Okay, so log base e is just natural log of 18 equals x. Calculate that. It's approximately 2.89. Number 11, same idea, but we need to isolate that e first. So I'm going to add the 8 to both sides, which gives me 34. And now I'm going to rewrite it as log base e equals the exponent of 34. Okay, if you make that calculation, natural log of 34, and then subtract 1 from both sides, you get 2.53. Same idea here, but we need to isolate that e. So I'm going to subtract 5. So I have 2 e to the 2x minus 3 equals 12. Divide by 2, so I have e to 2x minus 3 equals 6. And now I can rewrite in logarithmic form. So I have natural log equals to 2x minus 3. It's the natural log of 6 equals 2x minus 3. So that simplifies to 1.79 equals 2x minus 3. Add 3, divide by 2, you get your final answer of 2.40. Okay, so that's problems 1 through 12 on the expanded review.